This afternoon, in broad daylight, across the entire continental United States, the second planet from the Sun vanished. Not behind clouds, not behind haze, behind the Moon itself, in a clean geometric pass that astronomers call a lunar occultation, one the unaided eye could watch happen in real time for anyone who knew exactly where to look. At 2040 Universal Time on the 17th of June 2026, the thin crescent moon, only 11% illuminated and just 2 to 3 days past new, moved directly across the disk of Venus. For observers from the Caribbean Basin through the continental United States and into southern Canada, the brightest planet in the sky disappeared completely behind the unlit edge of the moon, was gone for the better part of an hour, and then re-emerged on the other side. This is the first daytime occultation of Venus visible from North America in 11 years. The next one favorable to this continent will not occur again until the early years of the next decade. Picture the actual mechanics of it, because they matter for what follows. Venus does not simply fade out. It does not dim gradually the way a star sets behind a horizon haze. At the moment of disappearance, the leading edge of the moon, the dark, unilluminated limb invisible to the eye against the daytime sky, advances directly across the planet's disk. Venus takes approximately 29 seconds to vanish completely, blinking out of a clear blue afternoon sky as though a switch had been thrown. Along the eastern seaboard, observers saw it happen at 3:49 inches the afternoon Eastern Time. In Austin, Texas, the disappearance came at 2:24 inches the afternoon Central Time. In Denver, the leading edge of the moon began its pass at 12:55 inches the afternoon Mountain Time. 3 different clocks, 3 different time zones, one continuous arc of shadow tracing itself across a continent in the middle of an ordinary Wednesday afternoon. For nearly an hour afterward, across the viewing corridor, the second brightest object in the solar system, after the sun and the moon, simply did not exist in the sky. Then, on the trailing edge of the lunar disk, it reappeared. This did not happen by accident, and it was not a surprise to anyone tracking it. The United States Naval Observatory, the Jet Propulsion Laboratory's DE-440 planetary ephemeris, and the International Occultation Timing Association had the exact second of disappearance and reappearance calculated for dozens of cities months in advance. This is one of the most precisely predictable categories of event in all of observational astronomy, governed by the orbital mechanics of 2 bodies, whose positions can be modeled with extraordinary accuracy, centuries into the future and centuries into the past. That predictability is not incidental to tonight's report. It is the reason the event could be tracked by ancient observers with no instruments at all, using nothing but the naked eye and a count of days. We will return to exactly how precisely they tracked it before this report is finished. This number is worth sitting with for a moment. 11 years. The last time the moon crossed in front of Venus in a way that observers in this country could see without specialized equipment, a different set of headlines occupied the news cycle, a different president occupied the White House, and most of the people watching this report tonight had not yet started paying attention to the sky. Celestial mechanics do not care about any of that. The moon orbits, Venus orbits, and on a predictable schedule governed by orbital geometry worked out to the second by the United States Naval Observatory and the Jet Propulsion Laboratory, the 2 bodies lined up again. This is not because the event itself is dangerous. It is not. Nothing about a planet passing behind the moon poses any threat to anyone watching from the ground. It matters because of what comes next in this report, and because the disappearance of Venus is one of the oldest, most carefully tracked, most consistently feared phenomena in the entire written record of human astronomy. Long before telescopes, before written mathematics, before most of the civilizations whose names we still recognize had built their first cities, someone was already watching Venus vanish from the sky and writing down what happened next. This report is going to show exactly who and exactly what they recorded before it is finished. Here is what we have prepared for tonight. We will start with the verified data, the precise timing of today's occultation, the agencies and observatories who tracked it, the orbital mechanics that make it rare, and the broader context of an unusually active month for planetary alignments in the evening sky, with Venus, Jupiter, and Mercury all visible together in the days surrounding this event. We will walk through exactly what was visible, where, and why this particular pass required extraordinary caution from anyone attempting to observe it. since pointing any optical instrument anywhere near the daytime sun carries permanent risk to eyesight. From there, we move into the historical record of how observers across multiple, unconnected civilizations treated the disappearance and reappearance of Venus, not as a curiosity, but as the single most important recurring astronomical event they tracked, year after year, across centuries. Then we go further back than the history of astronomy as it is usually taught. There is a clay tablet, recovered from a ruined Mesopotamian library, that catalogs the disappearance and reappearance of Venus for a 21-year stretch more than 3,000 years ago, in numbers precise enough that modern researchers still use it to anchor entire chronologies of the ancient world. There is a goddess in that same tradition, whose central myth is built entirely around a journey she takes when Venus vanishes from the sky, a journey through 7 gates, ending in death, followed by a return precisely when the planet reappears. There is a Mesoamerican manuscript, painted on bark paper and folded like an accordion, that tracks the same disappearance independently on the other side of the planet, using a completely different number system and a completely different mythology, arriving at the same underlying period to a precision that still surprises the researchers who study it. Both traditions treat the vanishing of Venus as something that has to be tracked exactly, named precisely, and treated as an omen with consequences for kings, harvests, and wars. This report is not going to claim what that convergence proves. The data from both records sits next to tonight's occultation for anyone watching to draw their own line between them. There is a number buried in the ancient Mesopotamian record concerning exactly how long Venus is permitted to remain absent from the sky before its disappearance is read as a warning rather than an ordinary cycle. That number exists. It was recorded on a tablet, copied and recopied for over 1,000 years specifically so it would not be lost. That number is not coming yet. It arrives later in tonight's report, once the full astronomical picture of what happened today has been laid out, so it can be measured against today's occultation directly. Before we go further, 3 things. If the pattern in tonight's report is useful, the way to make sure no future report is missed is to subscribe now. We file a new report every night, and the record only holds together for those who are here for the next one as well as this one. Second, leave a comment and tell us where you are watching from tonight. We read every one, and we are always struck by how far this audience actually stretches. Third, if this is the kind of report not seen anywhere else, the comment section is also the right place to tell us what to look at next. We are watching for it. This is also, frankly, the kind of report that rewards patience over a quick headline, so settle in. Here is what the data shows. At 2040 Universal Time on Wednesday, the 17th of June 2026, the Moon passed directly between Earth and Venus, producing a lunar occultation visible across the Caribbean, the contiguous United States, northern Mexico, and southern Canada, with the closest equivalent event for this continent not occurring again until 2029 at the earliest. There is a number in the ancient Babylonian record, a threshold measured in days, that determined whether a disappearance of Venus, like today's, was read as routine or as a warning. We will reach that exact number and what it required before this report closes. For now, the modern data. The Moon required exactly 29 seconds to fully cover the disk of Venus, a figure derived directly from the planet's angular diameter and the Moon's orbital velocity at the moment of contact. The event was tracked and confirmed by multiple independent sources. The United States Naval Observatory's Mica Ephemeris program, which calculates the positions of solar system bodies for the U.S. government and the broader scientific community, provided the baseline orbital data. The Jet Propulsion Laboratory's DE-440 planetary ephemeris, the same dataset NASA uses to navigate interplanetary spacecraft, supplied the precise 3-dimensional positions of the Moon and Venus required to calculate the occultation footprint down to fractions of a second. The International Occultation Timing Association, a global network of professional and amateur astronomers who specialize in exactly this category of event, published disappearance and reappearance times for dozens of named cities across the occultation path months in advance of June 17. At the moment of greatest geometric alignment, Venus carried an apparent magnitude of approximately -4, making it, after the Sun and the Moon, the brightest natural object in Earth's sky. This is bright enough that Venus is technically visible to the naked eye during full daylight under the right conditions, though daylight scattering in the atmosphere washes out most of the contrast that makes the planet so striking after sunset. The moon, by contrast, presented as a thin waxing crescent, only 11 to 14% illuminated, 2 to 3 days past the new moon phase. This detail matters more than it might first appear. A crescent this thin is difficult to locate against a bright daytime sky even when an observer knows precisely where to look, which is why the moon's position was used throughout the lead-up to the event as the navigational reference point for finding Venus, rather than the other way around. The geometry of the occultation placed both bodies in the constellation Cancer at an angular separation of approximately 38 degrees from the Sun. This separation distance is significant for reasons that go beyond simple visibility. Venus never strays farther than approximately 47 degrees from the Sun as observed from Earth, a constraint imposed by the planet's orbit lying inside Earth's own orbit around the Sun. A 38-degree separation placed today's event close to the edge of Venus's practical observing window, near its upcoming greatest eastern elongation in mid-August, when the planet will reach its maximum apparent distance from the Sun in the evening sky for this apparition. For the eastern half of the country, the disappearance occurred while Venus and the lunar crescent sat low in the southeastern sky, still well above the horizon and comfortably observable. For observers along the west coast, the geometry shifted enough that the event occurred closer to local sunset, compressing the usable observation window. Across the full footprint, the event also carried a secondary astronomical layer. Northeastern South America, including parts of Brazil, experienced the occultation after local sunset, under fully dark skies, producing a visually distinct version of the same geometric event, one where Venus disappeared against black sky rather than blue. Observing precautions for this event were not optional formalities. Because the occultation occurred in daylight, with Venus and the moon sitting approximately 38 degrees from the Sun, any optical instrument, whether binoculars, a telescope, or a camera with a zoom lens, carried genuine risk of catastrophic and irreversible eye damage if accidentally swept across the solar disk. The standard safety protocol distributed by observing organizations in advance of the event called for observers to position themselves in the complete shadow of a building, wall, or other physical structure, using the architectural edge as a fixed reference line to block the Sun entirely from the field of view while still leaving the relevant patch of sky open. This is a deceptively serious requirement. Unlike a solar eclipse, where the Sun's position is the explicit subject of observation and solar filters are an assumed prerequisite, a lunar occultation of a planet invites less caution by default because the Sun is incidental to the event rather than its subject. Multiple observing guides published in the week before June 17 explicitly warned that this incidental proximity to the Sun was the single greatest hazard of the day, greater than any hazard posed by the occultation itself. The moon's path through the sky in the days immediately surrounding the occultation adds further context to why this particular week drew unusual attention from the skywatching community. On June 16, the evening before the occultation, the moon passed 3 degrees north of Jupiter in the constellation Gemini, then moved on to pass within roughly half a degree of Venus later the same night, setting up the close pairing that would culminate in the following afternoon's occultation. After the daytime disappearance and reappearance of Venus on June 17 concluded, the same waxing crescent moon continued its eastward path against the background stars and entered the open star cluster Messier 44, commonly known as the Beehive Cluster, in the heart of the constellation Cancer, producing a second, lower-profile set of stellar occultations visible after sunset to observers with binoculars. This means the same single lunar crescent produced 2 distinct categories of occultation, of a planet in daylight and of star cluster members after dark, within a span of roughly 12 hours. It is worth establishing, in some detail, exactly who tracks an event like this, and why their data can be trusted at the level of precision we are reporting tonight. The United States Naval Observatory has operated continuously since 1830, and its core mission since the 19th century has been the precise determination of time and the positions of celestial bodies, originally in service of naval navigation and now in service of a far broader set of scientific, military, and civilian timing needs. The observatory's MICA software, the Multi-Year Interactive Computer Almanac, is the tool astronomers, navigators, and government agencies use to calculate exact rise times, set times, and conjunction geometry for the sun, moon, planets, and bright stars, accurate to fractions of an arcsecond. When local sunrise and sunset times were calculated for cities along tonight's occultation path, this is the system behind those numbers. The Jet Propulsion Laboratory, a federally funded research center managed for NASA by the California Institute of Technology, maintains the DE-440 planetary ephemeris, an extraordinarily refined model of the positions and motions of every major body in the solar system, built from centuries of accumulated observational data combined with decades of direct spacecraft tracking. This is not an estimate or an approximation. It is the same navigational dataset NASA uses to steer spacecraft across hundreds of millions of miles of empty space to a precise rendezvous with a planet, an asteroid, or a comet. When that level of precision is turned toward a much simpler question, where will the Moon and Venus be relative to each other at a specific seconds on a specific afternoon, the result is a forecast accurate enough to predict, to the second, when a planet will vanish from the sky, as observed from a specific street corner. The International Occultation Timing Association exists specifically to coordinate observation of events like this one. The organization compiles predicted disappearance and reappearance times for occultations of stars and planets by the Moon, and disseminates them in advance to a global network of professional and amateur observers, many of whom contribute their own precise timing observations back to the scientific record. For tonight's event, the association's published tables gave disappearance and reappearance times accurate to the second for cities across the entire occultation footprint, from the immersion point in the Caribbean through to the immersion point along the eastern edge of the visibility corridor. Beyond these three primary sources, NASA's own public-facing What's Up monthly Skywatching briefing, produced by the Jet Propulsion Laboratory's Outreach Office, had flagged the June 17 occultation as a headline event for the month as early as the start of June, well before the event occurred, giving the general public weeks of advance notice. The amateur and professional astronomy press, including outlets that specialize in precise observational astronomy, independently cross-published timing tables in the days immediately before the event, providing a layer of public redundancy on top of the official agency data. What this collective monitoring infrastructure demonstrates, beyond the immediate fact of tonight's occultation, is the sheer predictive power now available for an entire category of celestial mechanics that, for most of human history, could only be tracked through patient, generational observation. We will return to that distinction directly. The agencies named above did not discover that Venus disappears periodically. They calculated, to the second, exactly when a known, ancient, and exhaustively documented cycle of disappearance would next intersect with the Moon's position as observed from a specific set of coordinates on Earth's surface. The cycle itself is not a modern discovery at all. There is a secondary technical detail in tonight's data worth establishing now because it becomes directly relevant later in this report. Venus's orbit and the Moon's orbit are not synchronized with each other in any simple way, which means lunar occultations of Venus do not happen at fixed, predictable intervals the way some other periodic sky events do. Instead, they cluster into series. A given location on Earth will typically experience a run of several occultations spaced months apart, followed by a long gap of years before the geometry realigns favorably again for that location. Tonight's occultation is the first of 3 lunar occultations of Venus globally in 2026. The second will occur on September 14, favoring observers across Southeast Asia. The third will occur on November 7, favoring the southern tip of South America. None of the remaining 2 occultations in this series will be visible from North America. The contiguous United States will not see another favorable daytime occultation of Venus by the Moon until the period spanning 2029 to 2031, a gap of 3 to 5 years depending on the specific geometry of those future events. To understand why tonight's occultation connects to a body of historical records stretching back more than 3,000 years, it is necessary to understand the underlying cycle that governs when and why Venus disappears from Earth's sky at all. This is not the same phenomenon as a star or another planet simply setting below the horizon at the end of the night. Venus undergoes a structured, repeating, and fully predictable cycle of appearance and disappearance driven by the relative positions of Earth, Venus, and the Sun. And this cycle, known to modern astronomy as the synodic period, takes approximately 584 days to complete a full circuit. The mechanics work as follows. Venus orbits the Sun on an inside track relative to Earth, completing one circuit in just under 225 days, compared to Earth's 365. Because Venus is closer to the Sun, it is never visible in a fully dark sky at midnight the way an outer planet like Mars or Jupiter can be. Instead, Venus is always observed either rising ahead of the Sun in the eastern sky before dawn, the configuration known as the morning star, or trailing the Sun and visible after sunset in the western sky, the configuration known as the evening star. These two roles alternate, and the transition between them is marked by two distinct disappearance events. The first is called inferior conjunction, when Venus passes between Earth and the Sun, crossing from the evening sky to the morning sky. Around this conjunction, Venus disappears from view for a relatively short window, typically about 8 days, because its orbital path carries it close enough to the Sun's position in the sky that it is lost in solar glare, while its physical proximity to Earth at this point in the cycle means the disappearance window itself is brief. The second is called superior conjunction, when Venus passes behind the Sun, as seen from Earth, on the far side of its orbit, crossing from the morning sky back to the evening sky. This disappearance window is dramatically longer, typically stretching to around 50 days, sometimes longer, because Venus at superior conjunction is at its most distant point from Earth in the cycle and remains lost in the Sun's glare for a substantially extended period. Between these two disappearances, Venus spends roughly 260 days visible as the morning star, then vanishes at superior conjunction, then spends another roughly 260 days visible as the evening star, then vanishes again at inferior conjunction, and the cycle repeats. Add the appearance windows and the two disappearance windows together, and the total comes out to approximately 584 days. The synodic period, a number that ancient observers across multiple, geographically isolated civilizations independently measured to a precision that remains startling to researchers studying their records today. Tonight's occultation is not, on its own, one of these two structural disappearances. The Moon passing in front of Venus is a separate, shorter-term geometric coincidence layered on top of the longer synodic cycle, a chance alignment of the Moon's roughly 29-day orbital period with Venus's position on a given afternoon. But the reason tonight's event carries the weight it does, the reason it draws this level of attention from skywatchers and astronomers alike, is that it sits within the same broader pattern of Venus behaving, observably and on a strict timetable, exactly the way it has behaved for as long as anyone has been watching it. The Moon momentarily covering Venus is a small, precise demonstration of the same orbital clockwork that has, across thousands of years of separate human civilizations, produced the far more consequential disappearances at conjunction. This is the detail that connects tonight's astronomy desk to the ancient record we are about to examine. The cultures whose textual traditions we are about to walk through were not tracking lunar occultations of Venus specifically. They did not have the geometric tools to predict an event this localized and this brief. What they were tracking, with an accuracy that has been independently verified against modern retro-calculated ephemerides, was the broader synodic cycle itself. The roughly 8-day disappearance at inferior conjunction, the roughly 50-day disappearance at superior conjunction, and the alternation between Venus as morning star and Venus as evening star that the cycle produces. Tonight's occultation is a single, visually striking instance of Venus going dark in the sky. The ancient traditions we are about to cover were built around an entire civilizational practice of tracking exactly that kind of event, over and over, for generations, and writing down what they believed it meant. There is additional context worth noting about the broader sky in June 2026, because it situates tonight's occultation within a month of unusually active planetary visibility. Early in the month, Venus and Jupiter, the two brightest planets visible from Earth, appeared in close conjunction in the evening sky shortly after sunset, an alignment visible to the naked eye without any equipment. From June 11 through June 15, Mercury joined the configuration, producing what skywatchers described as a miniature parade of three planets low in the western sky after sunset. This planetary clustering, while a separate phenomenon from tonight's lunar occultation meant that the days leading into June 17 already had an unusual concentration of public and media attention on the evening sky, attention that primed observers to notice and ask questions about what then happened in broad daylight on the 17th. The summer solstice for the Northern Hemisphere arrives just 3 days after tonight's occultation, on the morning of June 21. This timing detail carries a secondary astronomical consequence worth noting. The steep angle of the ecliptic, the apparent path of the sun, moon, and planets across the sky, relative to the horizon at this time of year, works against optimal viewing conditions for events like aurora displays, an effect that is the inverse of the more favorable viewing geometry available during the spring and autumn equinoxes. This detail is unrelated to tonight's Venus occultation directly, but it is the kind of granular monitoring detail that the same agencies tracking Venus's position are simultaneously tracking across the full breadth of solar and lunar phenomena every day, regardless of which individual event draws public attention on a given night. That number will matter later in this report. Keep the figure of 50 days in mind, the length of Venus's disappearance at superior conjunction. We are going to return to it directly when we reach the ancient record, because the precise number of days a culture believed Venus could safely remain absent from the sky before something was considered wrong turns out to be a recorded, debated, and very specific figure. It is worth pausing here to address directly how observers without telescopes were able to track a cycle this intricate with the accuracy that the historical record demonstrates. The answer is not mysticism, and it is not luck. It is patient, generational, and frankly extraordinary naked-eye observation, sustained continuously over periods long enough for a civilization to notice that the same pattern of disappearance and reappearance kept repeating, and to begin recording exactly when each instance occurred against whatever calendar system that civilization used to track time. Venus, as already established, reaches an apparent magnitude bright enough to be the most conspicuous object in the night sky after the moon. Its disappearances and reappearances at the horizon are not subtle. A culture that watched the eastern or western horizon attentively every clear morning or evening across an unbroken span of years would notice Venus rising or setting against the background stars at a steadily shifting point, then notice it vanish entirely for a stretch of days, and then notice it reappear on the opposite horizon in the opposite role. Repeat that observation across enough cycles, and the underlying pattern becomes visible without any instrument beyond the human eye and a reliable method of counting days. What makes the surviving ancient records remarkable is not that this kind of naked-eye tracking was possible. It is the specific, numerical precision that several entirely separate civilizations independently achieved, and the fact that modern astronomers, working backward from precise orbital mechanics, have been able to verify that precision against the retro-calculated positions of Venus for the actual centuries in which these records were compiled. This is not a case of ambiguous, after-the-fact pattern matching. The dates, the day counts, and the cyclical structures recorded in the ancient documents we are about to examine can be checked mathematically against where Venus actually was in the sky on the specific days those records claim. In multiple cases, that check has been performed by professional astronomers and historians, and the ancient figures hold up. We want to be precise about what we are claiming and what we are not claiming, because the distinction matters for the rest of this report. We are not asserting that any ancient civilization possessed knowledge of celestial mechanics equivalent to a modern ephemeris, and we are not asserting that the disappearance of Venus carries any supernatural significance. The agencies named earlier in this report, the Naval Observatory, the Jet Propulsion Laboratory, the International Occultation Timing Association, have given us a complete, physically grounded explanation for tonight's occultation and for the broader synodic cycle that produces Venus's periodic disappearances. What we are documenting is a separate and, we think, equally significant fact that the precision of ancient naked-eye tracking of this exact cycle across multiple unconnected cultures was high enough that those records remain useful to modern researchers today, sometimes as chronological anchors for dating entire historical periods. The data is on the record in both places, the modern and the ancient. We are reporting what is in each, without collapsing the distinction between them. There is one more piece of monitoring context to establish before we move into the historical section. The current apparition of Venus, the specific window of visibility the planet is moving through right now, places it as an evening star through the remainder of the summer, building toward greatest eastern elongation, its maximum angular separation from the Sun in the evening sky on August 15. After that date, Venus will begin its approach back toward the Sun, heading toward its next inferior conjunction and the brief disappearance that accompanies it, the 8-day window described earlier in this report. That inferior conjunction, the shorter and more frequent of the two disappearance types, is not yet scheduled to occur for several months. Tonight's occultation, in other words, took place during a period when Venus was fully and routinely visible by the standards of its own cycle, in the comparatively unremarkable middle stretch of its current apparition as evening star. It was the Moon's path, not Venus's underlying cycle, that produced tonight's specific disappearance. We flag this distinction because the ancient traditions we are about to cover treated these two categories of disappearance very differently, and the difference matters for how precisely we can draw a line between tonight's event and the historical record. We will return to this coordinate, the constellation Cancer, and to the timing of today's occultation relative to the broader synodic cycle before the end of tonight's report. For now, the verified picture is complete. A precisely calculated, multiply confirmed, entirely safe astronomical event tracked by 3 independent agencies down to the second, embedded within a much older and much more consequential cycle of planetary disappearance that human civilizations have been recording with remarkable accuracy for thousands of years before any of those 3 agencies existed. There is additional infrastructure behind tonight's report worth detailing because it speaks to how thoroughly modern observation now covers an event of this kind, layered well beyond the 3 primary agencies already named. The Virtual Telescope Project, an Italian-based initiative that operates a network of robotic telescopes for public outreach and research purposes, provided live-streamed coverage of today's occultation, allowing observers outside the favorable visibility footprint, including across Europe, Asia, and Africa, where the event was not visible at all due to the geometry of the Moon's position relative to those longitudes, to watch the disappearance and reappearance in close to real time. This kind of public, freely available streaming coverage of a precise astronomical event did not exist in any comparable form even 2 decades ago, and it represents a direct, practical extension of the same agency-level tracking data already described, made accessible to anyone with an internet connection, rather than only to those standing in the right physical location on the right afternoon. Amateur observation networks also played a documented role. The International Occultation Timing Association does not simply publish predicted times. It actively collects observed timing data submitted by amateur astronomers who watch the actual disappearance and reappearance through their own equipment and report the precise second at which each event occurred from their specific location. This crowdsourced timing data feeds back into refining the broader ephemeris models used by professional agencies, meaning tonight's occultation, beyond being a public spectacle, also generated a small amount of genuine scientific data, contributing observational timing points that help refine the predictive models used for all future occultation calculations. We want to address directly why an event with this level of monitoring, this level of advanced prediction, and this level of safety still draws the attention this report is giving it. The honest answer is that precise predictability and significance are not opposites. An event being fully explained by orbital mechanics, fully anticipated by multiple independent agencies, and entirely safe to observe does not make it routine in any meaningful sense. It makes it a rare, scheduled appointment with a pattern that has been running uninterrupted for as long as the Moon and Venus have occupied their current orbits, a pattern that a handful of ancient civilizations managed to characterize with startling accuracy using nothing but patient observation, long before anyone could explain why the pattern existed at all. There is a historical irony embedded in tonight's event that bears mentioning before we move into the deeper historical record. Galileo Galilei, observing Venus through one of the earliest telescopes in the early 17th century, documented that the planet displayed phases, similar to the Moon's, waxing and waning as its position relative to Earth and the Sun changed across the synodic cycle. This observation, made in 1610, provided some of the first direct telescopic evidence supporting the Copernican model of a sun-centered solar system, because the specific pattern of phases Galileo observed was only consistent with Venus orbiting the Sun, not the Earth. In other words, the same astronomical body at the center of tonight's occultation was also at the center of one of the pivotal observational moments in the entire history of the scientific revolution. Galileo's telescope showed, for the first time with instrumental confirmation, the mechanical reality underlying a cycle that other civilizations, with no telescope at all, had already been tracking by eye for thousands of years. We mention this not as a curiosity, but because it establishes a continuous thread from naked eye observation in the ancient world through Galileo's telescope in 1610 to the Naval Observatory's Mica software and the Jet Propulsion Laboratory's DE 440 ephemeris in 2026, of human beings watching the exact same astronomical relationship and refining their understanding of it without ever changing the underlying phenomenon being observed. The monitoring outlook going forward is well established and well documented. NASA's Jet Propulsion Laboratory continues to track Venus's position as part of its routine solar system monitoring, alongside its tracking of near-Earth asteroids and other solar system bodies. The International Occultation Timing Association has already published predicted circumstances for the next 2 occultations in this series: September 14 over Southeast Asia and November 7 over the southern tip of South America, along with preliminary data for the occultation series that will next favor North America beginning in 2029. Venus itself will continue its current apparition as evening star through the rest of the summer, reaching greatest eastern elongation on August 15, before beginning its long approach back toward the Sun and its next inferior conjunction disappearance later in the year. None of this requires speculation. It is calculated, published, and available to anyone who wants to verify it directly against the agencies named throughout this section. What is not fully covered by any of those agencies, and what we want to spend the remainder of this report addressing, is the question of what Venus's disappearance meant to the people who watched it before any of those agencies existed, who had no ephemeris, no telescope, and no DE 440 model, and who nonetheless tracked this exact cycle, recorded it in writing, and built entire religious, political, and agricultural calendars around predicting when it would happen next. There is a second retention point worth planting here. We mentioned earlier that the ancient Babylonian record contains a specific day count threshold for how long Venus could disappear before the absence was read as something other than routine. We are going to reach that number, and the goddess whose entire mythology was structured around it, in the next 2 sections of this report. Hold that thought. The historical and ancient record is about to make tonight's occultation considerably more interesting than a single afternoon's sky show. Before we leave the modern data entirely, it is worth situating tonight's occultation within the broader context of what else the same monitoring agencies were tracking this week, because the contrast is instructive. NASA's Center for Near-Earth Object Studies, operating out of the Jet Propulsion Laboratory, maintains continuous tracking of small asteroids passing near Earth, several of which made close approaches in the days immediately surrounding tonight's occultation. None of these objects posed any threat. The closest, a small body roughly 50 to 100 feet across, passed at a distance of several 100,000 miles, well outside any zone of concern, and was tracked with the same DE 440 ephemeris precision used to calculate tonight's Venus occultation. We mention this only to establish the scale of what modern monitoring infrastructure now handles as routine background work: precise tracking of small asteroids, precise tracking of planetary occultations, precise tracking of solar activity, all running simultaneously, all logged, all available to the public, in a way that would have been unimaginable to the ancient observers whose work we are about to examine. Space weather monitoring through the same week showed comparatively quiet conditions. The National Oceanic and Atmospheric Administration's Space Weather Prediction Center reported Earth's magnetic field remaining at quiet to unsettled levels in the days surrounding the occultation, with only minor solar flare activity from a handful of magnetically simple sunspot regions and no geomagnetic storm conditions in effect. A glancing influence from a coronal mass ejection that left the Sun several days earlier was anticipated to brush past Earth without producing significant magnetic disturbance. This detail matters for one specific reason. The same agencies capable of forecasting a geomagnetic storm to within a day and an occultation to within a second reported nothing unusual in Earth's broader space environment this week beyond the occultation itself. Tonight's event stands on its own, mechanically isolated from any other concurrent space weather activity, which makes it a clean, uncomplicated data point for the comparison we are about to draw against the ancient record. It is also worth noting, briefly, the practical difficulty of observing tonight's event, because the difficulty itself is part of what makes the ancient tracking record so remarkable by comparison. Multiple observing guides published in advance of June 17 specifically warned that locating the moon's thin crescent against a bright daytime sky is a genuine challenge even for experienced observers, requiring patience, a clear deep blue sky, and often the aid of binoculars or a smartphone camera's zoom function to first acquire the crescent before then locating Venus relative to it. Several published guides recommended using the edge of a building or wall as a fixed visual anchor, not only for solar safety, but simply to help the eye lock onto a faint daytime target against a featureless blue background. This was, by every account, a demanding observation, even with full advanced knowledge of the precise second at which the event would occur, the precise coordinates in the sky to look toward, and the benefit of optical aids unavailable to any observer before the invention of the telescope. Hold that difficulty in mind as we move forward. Civilizations, thousands of years before telescopes, before precise written ephemerides, before any concept of orbital mechanics, were not tracking a single daytime occultation. They were tracking the full Venus synodic cycle, the 8-day and 50-day disappearances at conjunction across years and then generations, with enough consistency that the patterns they recorded can still be checked against modern retrocalculation today. The difficulty involved in spotting one thin crescent moon against a blue afternoon sky, even with all the advantages of the modern world, gives some sense of the discipline required to track a slower, longer, and far less visually obvious cycle using nothing but the unaided eye, repeated faithfully across an entire human lifetime and then handed down to the next generation of observers. The verified picture, in full, stands as follows. A precisely calculated, multiply confirmed, entirely safe lunar occultation of Venus occurred this afternoon, visible across a defined footprint stretching from the Caribbean through the continental United States and into southern Canada, the first such daytime event favorable to this continent in 11 years. It sits within the broader and far older Venus synodic cycle, a 584-day pattern of appearance and disappearance that ancient civilizations independently tracked with documented precision. The agencies responsible for tonight's data, the Naval Observatory, the Jet Propulsion Laboratory, and the International Occultation Timing Association, working from orbital mechanics models refined over centuries of observation and decades of direct spacecraft tracking, provided complete, transparent, physically grounded explanations for every element of what was visible today. That is the modern record, established and complete. We turn now to what came before it. Before this section closes, it is worth returning to the three primary agencies named earlier and establishing, in more specific terms, exactly why their data carries the authority we have been assigning it throughout this report, because the precision involved is easy to state and harder to fully appreciate. The United States Naval Observatory's role in American timekeeping predates almost every other piece of federal scientific infrastructure still operating today. Founded in 1830 as the depot of charts and instruments, it became the United States Naval Observatory in 1844, and its core responsibility from the beginning was producing the precise astronomical and timing data the United States Navy needed for accurate celestial navigation at a time when a ship's position at sea could only be determined by precise reference to the calculated positions of the sun, moon, planets, and stars. That original mission, determining exact positions of celestial bodies to support exact determination of position on Earth, has not changed in its fundamental logic, even as the tools have evolved from sextants and chronometers to the Mica software used to calculate tonight's occultation circumstances. The observatory today also operates the master clock for the United States Department of Defense and contributes to the international standard for coordinated universal time, the same UTC standard used to timestamp tonight's occultation at 2040. The Jet Propulsion Laboratory's authority on this subject rests on a different but equally rigorous foundation. As a NASA field center managed by Caltech, JPL's primary mission since its founding has been the design, construction, and navigation of robotic spacecraft across the solar system, a task that is fundamentally impossible without an extremely precise model of where every relevant body in the solar system will be at every point in time. The DE-440 ephemeris is the product of this operational necessity. It has been validated not through abstract calculation alone, but through direct comparison against decades of spacecraft tracking data, radar ranging of planetary surfaces, and laser ranging of the Moon's distance from Earth, accumulated since the early space age. When DE-440 predicts that Venus and the Moon will align at a specific second on a specific afternoon, that prediction carries the same confidence level that allows JPL to successfully navigate a spacecraft to a precise rendezvous with a comet or asteroid millions of miles from Earth. We move now from the verified instrumental record into the historical one. The historical record of careful human observation of Venus does not begin with ancient priests reading omens. It runs through a more recent and more thoroughly documented period as well, one that bridges the ancient material we are about to examine and the precise agency data already covered, and it is worth walking through before we go further back. The transit of Venus, a rarer and visually distinct cousin of tonight's lunar occultation, occurs when Venus passes directly between Earth and the Sun, becoming visible as a small black disk crawling across the Sun's face. Unlike tonight's event, transits of Venus are not just rare, they follow one of the strangest and most irregular long-term patterns in naked-eye astronomy. Pairs of transits separated by 8 years, then gaps of over a century before the next pair. The astronomer Johannes Kepler, working from his own refined planetary tables in the early 17th century, was the first to successfully predict a transit of Venus, calculating that one would occur in 1631, though the event itself was not visible from Europe. It was the English astronomer Jeremiah Horrocks who, in 1639, made the first documented direct observation of a Venus transit, projecting the Sun's image through a simple telescope onto a screen and watching Venus cross the solar disk in real time, a feat of both calculation and patience that predates the founding of the United States Naval Observatory by nearly 2 centuries. The 18th and 19th century transits of Venus, occurring in pairs in 1761 and 1769, then again in 1874 and 1882, became the focus of some of the largest coordinated international scientific expeditions in history up to that point. Astronomers from multiple nations traveled to remote observation points around the globe, specifically to time the transit from widely separated locations, because comparing those timed observations allowed, for the first time, a reasonably accurate calculation of the actual distance between Earth and the Sun, the astronomical unit, a figure that underpins essentially every other distance measurement in the solar system. Captain James Cook's first voyage to the Pacific in 1769 was undertaken in significant part to observe that year's transit from Tahiti, placing the pursuit of precise Venus data directly at the center of one of the most consequential exploratory voyages in European maritime history. The most recent transits, a pair in 2004 and 2012, were observed by millions worldwide using modern solar filters and were broadcast live online, the direct technological descendant of the same observational tradition that sent Cook to Tahiti and that streamed tonight's occultation through the Virtual Telescope project. We connect this as to a broader, earlier observation. Closer in spirit to tonight's specific event is the long observational record of lunar occultations themselves, a category of astronomical event that professional observatories have systematically timed since at least the 18th century, specifically because before the era of laser ranging and spacecraft tracking, precisely timed occultations were one of the most accurate available methods for refining the Moon's exact orbital position. The Royal Greenwich Observatory, founded in 1675, maintained occultation timing as a standard observational program for centuries, and the data those historical observations produced still contributes to the long baseline orbital models used today. Tonight's 29-second disappearance of Venus behind the Moon's leading limb sits at the end of an unbroken 3.5-century tradition of professional astronomers, treating exactly this category of event as worth the trouble of precise, repeated, recorded observation. There is a further historical echo specific to Venus's brightness and visibility that connects directly to tonight's daytime event. Multiple documented historical accounts describe Venus being visible to the naked eye in full daylight under favorable conditions long before any agency formally tracked, predicted such sightings. Reports of Venus seen at midday circulated during the Roman Republic, were noted by several medieval European chroniclers, and were documented again in the United States during the 1980s, when Venus's daytime visibility briefly became a subject of public curiosity after sightings were independently reported by multiple observers unaware of each other's accounts. Sightings later confirmed as astronomically consistent with Venus's position and brightness on the relevant dates. This recurring thread, ordinary people, across centuries, independently noticing the same impossibly bright daytime object and feeling compelled to record the sighting, is itself a smaller-scale version of the same impulse that produced the much older and much more systematic ancient traditions this report turns to next. It is worth pausing on one specific historical comparison because it speaks directly to the gap between casual sighting and systematic tracking that separates the documented European record from what we are about to examine in the Ancienne Tradition. European astronomers of the 16th and 17th centuries, working with newly invented telescopes and emerging mathematical models, were in many respects rediscovering, confirming, and formalizing patterns that had already been independently documented in different notation systems and for different stated purposes by civilizations on other continents centuries or millennia earlier. Tycho Brahe's exhaustive naked-eye observational records of planetary positions in the late 16th century, compiled without a telescope at all using purpose-built quadrants and sextants of his own design, are still regarded by historians of astronomy as a benchmark of pre-telescopic observational precision. Brahe's data on Venus's positions, gathered over decades at his Uraniborg Observatory in Denmark, would later become essential to Kepler's derivation of the laws of planetary motion. The discipline involved sustained nightly observation, careful instrument calibration, and meticulous record-keeping across years, mirrors almost exactly the methodology that the ancient civilizations we examine next had already been applying to this same planet for a much longer span of time, using a different set of tools and an entirely different interpretive framework. There is a 20th and 21st century chapter to this same historical thread that bears directly on how seriously the ancient records discussed in the next section of this report should be taken. Beginning in the early 20th century and continuing through the present, historians of science and astronomers working jointly have applied modern retrocalculation using the same category of orbital mechanics models that produced tonight's DE 440 ephemeris data to check ancient astronomical records against where Venus, the Moon, and other bodies actually were in the sky on the specific dates those ancient records claim. This is not a casual or speculative process. It involves running the orbital equations backward by thousands of years and comparing the output, an exact predicted date and circumstance, against the date and circumstance written on a specific surviving tablet or in a specific surviving manuscript. Franz Xaver Kugler, a German Jesuit scholar working in the early 20th century, was among the first to apply this kind of rigorous astronomical cross-checking to Babylonian celestial records, and his work remains foundational to the field. Successive generations of scholars, using progressively more refined retrocalculation tools, have continued this verification work into the 21st century, and the records we are about to walk through have, in every case discussed in this report, been subjected to exactly this kind of independent astronomical check. Where ancient and modern calculation disagree, scholars have generally found explanations rooted in transcription or translation, copying errors made by scribes recopying a damaged or aging tablet, calendar conversion discrepancies, or atmospheric refraction effects near the horizon that ancient observers could not account for. Where the two agree, and in the cases we are about to cover, they agree closely, The convergence stands as one of the more remarkable cross-checks available between the textual record of antiquity and the hard mathematics of celestial mechanics. That number will matter again shortly. The Naval Observatory's modern calculation placed today's disappearance at 29 seconds. The historical timing tradition that the Greenwich Observatory and its successors built over 3.5 centuries exists specifically because that kind of precise and seconds-level measurement of lunar position has scientific value independent of any single event's novelty. Keep that continuity of precise measurement in mind as we move into a period when the available instruments were nothing more than the human eye, sustained over not centuries but millennia. What the modern historical record demonstrates across the transit expeditions, the Greenwich Occultation program, and the recurring documented sightings of daytime Venus is a consistent pattern. This specific planet has drawn an unusually high degree of sustained, careful, motivated observation across every era of human history for which we have written records, from antiquity through the scientific revolution and into the present monitoring infrastructure already described. The reasons for that sustained attention shift across eras, from religious omen reading, to precise solar system cartography, to public spectacle, to citizen science contributing real orbital refinement data, but the underlying object of attention, and in a meaningful sense the underlying cycle being tracked, has not changed at all. The pattern in the modern and early modern record is clear, but we do not stop at the documented history of telescopes and expeditions. There is an older layer, tablets, manuscripts, and oral traditions that log this exact signature, the disappearance and reappearance of Venus, long before any instrument existed to confirm what was being observed. That layer is what comes next. The oldest systematic written record of Venus's disappearance and reappearance to survive into the present comes from ancient Mesopotamia, and it is preserved in a document modern scholars call the Venus Tablet of Amisaduqa. The International Occultation Timing Association occupies a different position in this network, functioning less as a single authoritative data source and more as the coordinating body for an entire global community of professional and amateur observers who specialize in exactly this category of astronomical event. Lunar occultations of stars, planets, and other bodies have long served a specific scientific purpose beyond public spectacle. Precise timing of the moment of disappearance and reappearance, especially when observed simultaneously from multiple separated locations, can be used to refine measurements of the moon's exact position and motion, and in some historical cases, has been used to detect previously unknown details about the shape of a star or the structure of a planet's atmosphere as it briefly passed behind the lunar limb. The association's role in coordinating, collecting, and publishing this observational data places it at the center of a category of citizen science that has operated continuously in steadily refined form, since long before space-based tracking made some of its original purposes less essential. Taken together, these three sources represent three different but converging lines of verification: government-grade timekeeping and navigation infrastructure, spacecraft-grade planetary positioning data, and a global network of dedicated observational astronomers cross-checking the predictions in real time from the ground. When all three independently converge on the same second, the same coordinates, and the same 29-second duration for tonight's occultation, the resulting figure is about as well verified as any single data point in observational astronomy can be. There is a final piece of secondary effect worth logging before we move forward, concerning the public and media response to tonight's event specifically. Coverage of the occultation appeared across major science and general interest outlets in the days leading up to and on the day of the event itself, with explicit safety guidance repeated consistently across nearly every published account, a level of coordinated public messaging that itself reflects how seriously the observing community treats the genuine, if often underappreciated, risk of casual binocular or telescope use anywhere near the daytime sun. This is not a minor footnote. Multiple published guides specifically flag this event as carrying elevated risk precisely because its daytime timing and its status as a planetary rather than solar event might lead an inexperienced observer to underestimate the danger of sweeping an instrument across the sky without first establishing exactly where the sun was. We have now established the complete verified record for tonight's astronomical event. precise timing, the agencies responsible for that precision, the underlying synodic mechanics that govern when Venus disappears and reappears at all, the broader context of this unusually active month for planetary visibility, and the safety considerations that shaped how the event was observed and reported. Every element of this picture is transparent, sourced, and verifiable against public agency data. What we turn to next is a separate question entirely, one that no modern space agency is in the business of answering because it falls outside the domain of orbital mechanics altogether. What did it mean to the people who watched this exact cycle play out across the sky for millennia before anyone could explain why it happened when Venus disappeared? One additional category of secondary effect deserves mention before we close out the verified data, because it speaks to the broader discipline of monitoring that underlies tonight's report, even though it is unrelated to Venus specifically. The same week as tonight's occultation, the Naval Observatory's broader almanac calculations were also tracking the Moon's own perigee and apogee, the closest and farthest points in its monthly orbit around Earth, a cycle that affects the height of ocean tides, independent of anything happening with Venus. This is, again, a separate phenomenon from tonight's occultation, but it illustrates the scale of the monitoring apparatus operating continuously in the background. The same orbital mechanics models capable of placing the Moon directly in front of Venus to the second are simultaneously tracking the Moon's distance from Earth for the purpose of tidal forecasting, lunar laser ranging experiments, and spacecraft mission planning, all running in parallel, all day, every day, regardless of which individual alignment happens to draw public attention on a given afternoon. It is this scale of constant, overlapping, highly precise monitoring that makes the contrast with the ancient records so stark. Modern agencies do not single out Venus for special attention. They track everything, continuously, as a matter of routine infrastructure, and Venus's disappearance behind the Moon this afternoon was simply one calculated output among thousands the same systems produce in an average month. The civilizations we are about to examine had no equivalent infrastructure. They had the sky, sustained attention, and a method of counting days. And from those tools alone, working without any of the apparatus just described, they extracted a level of precision about this one specific cycle, the appearance and disappearance of Venus, that remains impressive by any modern standard of naked-eye observational science. We want to flag one more retention point before moving forward. There is a particular number, the length in days, that one ancient civilization, specifically associated with a normal, expected disappearance of Venus at conjunction, against which any unusually short or unusually long absence would be measured and interpreted. That number has been mentioned but not yet stated. By the time we reach the end of the ancient records section of this report, that number will be on the table, alongside the specific astronomical agency record built around it. There is one further dimension of tonight's verified record worth establishing before we leave the modern data behind, concerning how rare events of this specific type, daytime occultations of Venus visible to a large, accessible population center, actually are across the full span of recorded astronomical history, not merely within living memory. Lunar occultations of planets happen with some regularity somewhere on Earth. Because the Moon's orbital path carries it across the entire band of the zodiac roughly once a month, and because the visible planets all lie close to that same band, the Moon passes in front of one planet or another with reasonable frequency when averaged across the whole globe. What makes a specific occultation rare is not the underlying mechanism, but the combination of three independent conditions all aligning at once. The event must be visible from a TVU, populated, accessible region of Earth. It must occur during daylight hours specifically for an event to qualify as the unusual daytime spectacle this one represents, and the occulted body must be bright enough, as Venus uniquely is among the planets, to be observable at all against a lit sky. Mercury, Mars, Jupiter, and Saturn are all occulted by the Moon on various occasions throughout any given year, but none of them approached the -4 magnitude brightness that makes Venus the only planet realistically observable during full daylight without specialized equipment. This is why the astronomy press specifically flagged tonight's event as the undisputed standout sky event of the month and one of the most anticipated occultations of the entire year, rather than treating it as routine. The historical frequency data bears this out directly. The most recent comparable daytime occultation of Venus visible from North America occurred 11 years before tonight's event. The IOTA's own published records describe this occultation series as one of the final favorable daytime passes for the contiguous United States before a multi-year gap opens, with the next viable occultation not expected until the 2029 to 2031 window. Across a typical human lifetime, an attentive skywatcher living in North America might reasonably expect to witness perhaps 3 to 5 events of this specific caliber, a rare allocation for an event governed by mechanics as regular and predictable as the ones described throughout this section. This rarity, combined with the underlying predictability, is precisely the combination that made Venus such a significant object of study for ancient observers in the first place. A fully chaotic, unpredictable celestial phenomenon would have been difficult for any pre-telescopic civilization to track with consistency, because there would have been no underlying pattern to discover. A completely mundane, constant phenomenon, visible every single night without variation, would have drawn comparatively little special attention because there would have been nothing notable about its behavior to record. Venus occupies a middle position that turns out to be unusually well suited to long-term naked eye study, regular enough that careful, sustained observation reveals a clear and learnable pattern, but irregular enough in its specific appearances, with the alternation between morning star and evening star, the abrupt disappearances at conjunction, and the cycling positions against the background stars, that the pattern itself becomes worth tracking, predicting, and eventually building an entire system of religious and civic meaning around. That combination of qualities, predictable enough to track, distinctive enough to matter, is the through line connecting tonight's daylight occultation over North America to the clay tablets, painted manuscripts, and oral traditions we are about to examine. None of the civilizations whose records we are about to cover were reacting to a singular, unprecedented event the way today's occultation might appear to a casual modern observer encountering it for the first time. They were reacting to, and meticulously documenting, the same recurring cycle this report has just spent its entire length explaining in modern scientific terms. The difference between their record and ours is not the underlying phenomenon. It is the framework used to understand it, and the meaning assigned to what was, in every case, the exact same astronomical event. It is worth being explicit, one final time, about the boundary this report draws and intends to hold for its remainder. Everything stated up to this point is sourced directly to named agencies, named software, and named observational networks, each independently verifiable. Nothing in the modern record requires interpretation beyond the data itself. What follows is a different category of material entirely. Documented historical and textual evidence of how separate human civilizations understood and responded to this same astronomical cycle, presented with the same standard of sourcing applied throughout this section, naming the specific texts, the specific translators, and the specific scholarly additions involved. This report is not asking anyone to believe anything beyond what the historical record itself contains. It is worth considering what it means that the record exists, in this much detail, in this many separate places, describing this one specific cycle, with this much precision, for this long. Taken together, the mythological and the astronomical Mesopotamian traditions describe the same underlying phenomenon from two different angles, generated by the same broad culture across many centuries. The astronomers recorded exactly when Venus disappeared and for how long, building a working, predictive, and omen-based document. The mythographers told a story, set in divine rather than mechanical terms, about a goddess who undergoes death and disappearance and returns transformed, a narrative shape that mirrors the astronomical reality with enough specificity that modern scholars continue to treat the connection as more than coincidental. Both traditions agree on the same essential observation: Venus's absence from the sky is not nothing. It is a passage, a transformation, a period during which something important and consequential is happening, even if it cannot be directly observed while it occurs. On the opposite side of the planet, with no contact, no shared written language, and no possible transmission of ideas between the two cultures, The Maya civilization of Mesoamerica independently developed its own systematic, written tracking of Venus's exact same disappearance and reappearance cycle, achieving a level of numerical precision that researchers studying the surviving document still find remarkable. The document in question is known as the Dresden Codex, named for the German city whose royal library has held it since the 18th century. It is one of only 4 surviving pre-Columbian Maya books, painted on bark paper treated with a lime wash and folded accordion style, that survived the mass destruction of Maya written material carried out during the Spanish conquest and colonial period. Scholars date the Dresden Codex itself as a physical artifact to sometime in the 11th to 12th centuries, though its content is understood to preserve and transmit astronomical knowledge and calendrical systems considerably older than the manuscript's physical creation. Recent scholarship, including a detailed rereading of the manuscript's introductory page by the researcher Gerardo Aldana, has connected the Venus table's original astronomical correction specifically to the city of Chichen Itza, suggesting the underlying observational work may trace to a particular royal court and a particular historical figure during that city's height. 5 consecutive pages of the Codex, conventionally numbered 46 through 50, are dedicated entirely to what scholars call the Venus table. The table tracks Venus across repeating cycles using the 2 interlocking Maya calendar systems, the 260-day sacred Tzolk'in and the longer 365-day solar calendar, structured so that a single pass through all 5 pages accounts for 5 complete synodic periods of Venus. Each page divides the cycle into 4 distinct phases, recorded in dot and bar numerals as a sequence of day counts: 236 days, 90 days, 250 days, and 8 days, a sequence that sums to 584, the precise whole number approximation of Venus's true synodic period that this report's earlier section already established. The first of these 4 numbers corresponds to Venus's stretch of visibility as morning star. The second, 90 days, corresponds to the disappearance at superior conjunction. The third corresponds to Venus's visibility as evening star. The fourth and shortest figure, 8 days, corresponds to the disappearance at inferior conjunction, the same shorter conjunction window discussed earlier in this report, and the specific interval the Maya scribes singled out in the Codex's own imagery as the most dangerous point in the entire cycle. The visual material accompanying the numerical table is explicit about the stakes the Maya attached to this specific moment. On the pages associated with the 8-day inferior conjunction disappearance, the Codex depicts the deified personification of Venus armed with a spear and an atlatl, a spear-throwing weapon shown in the act of menacing or directly attacking a series of named victims, including figures associated with maize, water, and other essential resources. The eminent 20th century Maya scholar J. Eric S. Thompson, whose foundational work on the Codex remains widely cited, described the spears in this imagery as a direct symbolic representation of the planet's rays, understood as death-dealing shafts of light at the precise moment of its reappearance. The clear implication, consistent across the iconography on all 5 pages, is that the moment Venus re-emerged from its shorter disappearance was treated as a moment of genuine danger, one requiring specific ritual observance to manage. This connects directly to a parallel tradition recorded among the later Aztec civilization of central Mexico, who inherited and adapted significant elements of earlier Mesoamerican Venus tracking practice. The Codex Chimalpopoca, a colonial-era compilation of earlier Nahuatl language mythological material, preserves the story of Quetzalcoatl, the feathered serpent deity, who, after his symbolic death, is described as transforming into the morning star. The text states explicitly that after his death he disappeared for 4 days and then spent 4 additional days fashioning darts for himself before reappearing, an 8-day total that corresponds precisely to the inferior conjunction disappearance window recorded independently in the Dresden Codex's numerical table. Researchers studying both texts together have noted that this Aztec narrative detail, the explicit 8-day count attached to a story of death, transformation, and reappearance as Venus, mirrors the Dresden Codex's own numerical structure closely enough to suggest a shared underlying Mesoamerican tradition of associating this specific 8-day figure with both Danger and renewal. The precision of the Dresden Codex's underlying numerical structure has been the subject of extensive modern technical analysis. Researchers studying the table's full sequence of recorded dates, running to 65 total synodic periods across the entire document, the equivalent of 104 years, have confirmed that the table's seasonal placement of Venus events, when checked against modern retro-calculated planetary positions for the relevant centuries, holds together with an internal consistency that required deliberate, sophisticated correction by the original Maya astronomers to maintain across such a long span. This is not a simple static count. It is evidence of an active observational tradition, one that periodically adjusted its own internal calendar to keep pace with the true, slightly irregular behavior of the actual planet, sustained by named royal courts across multiple generations. There is a direct symmetry worth stating plainly. The Babylonian scribes who compiled the Venus tablet of Amisaduqa and the Maya astronomers who compiled the Dresden Codex Venus table never had any contact with each other, shared no written language, no common calendar, and developed entirely independent civilizations separated by an ocean neither could cross. Both arrived, through sustained naked-eye observation alone, at the same underlying 8-year, 5 synodic period structure governing Venus's behavior. Both singled out the shorter, roughly week-long disappearance at inferior conjunction as the specific moment of greatest danger and significance within the broader cycle. Both recorded that significance in writing, in documents their respective civilizations considered important enough to preserve, recopy, and in the Maya case, actively correct and maintain across more than a century of continuous observation. The data is on the record in both places. The interpretation belongs to you. This report flagged earlier that there was a specific number on record, the day count threshold one ancient civilization used to judge whether a disappearance of Venus was ordinary or a cause for alarm. Here is that number, in full, as the Babylonian record states it. The Venus tablet of Amisaduqa's omen entries treat the 8-year cycle of disappearances as built from 2 structurally different events, and the tablet's scribes recorded a specific expected duration for each. At inferior conjunction, the shorter passage, the tablet's entries cluster around an absence of approximately 3 days, occasionally extending toward a week, depending on the specific cycle being recorded, a figure that matches closely with the 8-day inferior conjunction window independently recorded an ocean away in the Maya Dresden Codex. At superior conjunction, the far longer passage, the omen tradition recorded in Enuma Anu Enlil, treats a disappearance of around 70 days as the outer edge of the expected, ordinary range. The Grokipedia summary of recent scholarship on this tablet states the threshold directly. A disappearance shorter than 70 days at superior conjunction was read as a favorable omen, predicting prosperity and stability for the king and the land, while an absence stretching meaningfully longer than that threshold was read as a warning of famine or defeat. 70 days. That is the specific figure the Babylonian astrologers used to separate routine celestial behavior from behavior that demanded the king's attention. We want to be exact about what this means and does not mean for tonight's occultation. The Babylonian 70-day threshold concerns the long disappearance at superior conjunction, the structural absence built into Venus's own orbital cycle, not the brief, separate phenomenon of a lunar occultation like the one this report opened with. Tonight's event was not a disappearance of Venus at conjunction at all. It was the moon passing in front of an already visible Venus for less than a minute, a different mechanism entirely from the 50 to 70-day conjunction window the ancient astrologers were tracking. We draw this distinction deliberately because collapsing the two would overstate the connection between tonight's specific sky event and the ancient omen tradition. What the two events share is not identity. It is membership in the same broader phenomenon, the periodic disappearance of Venus from human view, a phenomenon multiple separated civilizations independently decided was significant enough to track, name, and number with exactly this kind of precision. 4 separate traditions have now been placed on the record in this section. The Babylonian astronomical omen tradition of the Venus tablet, the Sumerian and Akkadian mythological tradition of Inanna's descent, the Maya astronomical tradition of the Dresden Codex Venus table, and the Aztec mythological tradition preserved in the Codex Chimalpopoca's account of Quetzalcoatl. 2 are primarily scientific in character, built from sustained numerical observation. Two are primarily religious and narrative in character, built from story and symbol. All four describe, independently or through documented cultural transmission within their own regions, the same underlying astronomical phenomenon. This report opened by observing directly. Venus periodically vanishes from the sky and reliably returns. The tablet takes its name from the Babylonian king Amisaduqa, the fourth ruler after the more famous Hammurabi, whose reign modern chronologists place in the middle of the second millennium BCE, with the most widely used dating placing the original observations between approximately 1646 and 1626 BCE. The surviving copies we actually possess today, however, are considerably younger than the observations themselves. The most complete exemplar, designated K. 160 by the scholars who catalog it, was recovered from the ruined library of the Assyrian king Ashurbanipal at Nineveh, a library deliberately assembled in the 7th century BCE, specifically to preserve the accumulated scholarly and astronomical knowledge of the preceding centuries. This means the text we read today is a 7th century BCE copy, made by trained scribes specifically because the underlying data was considered valuable enough, nearly 1,000 years after the original observations, to be carefully recopied and preserved beyond K. 160. Scholars have identified more than 20 separate fragments of this same text, recovered from multiple sites across ancient Mesopotamia, including Nineveh, Sippar, and Ur, with one additional late Babylonian fragment, catalogued as BM 32107, published as recently as the early 21st century, demonstrating that research into this specific document continues actively into the present day. The tablet itself forms a single chapter, numbered Tablet 63, within a much larger compilation known as Enuma Anu Enlil, a title drawn from its opening words, meaning roughly, in the days of Anu and Enlil, referring to two of the principal gods of the Mesopotamian pantheon. Enuma Anu Enlil is not a narrative text. It is a comprehensive compendium of celestial omens, observations of the moon, the sun, the planets, and the stars, paired systematically with their interpreted meaning for the king and the land. Tablet 63 specifically isolates the planet Venus, identified in the Babylonian tradition with the goddess Inanna, and records, in remarkably granular detail, the rising times of Venus and the precise dates of its first and last visibility on the horizon before sunrise and after sunset, expressed using the Babylonian lunar calendar across a continuous 21-year span. This is where the tablet's significance to modern science becomes concrete. Venus's true synodic period, the same 584-day cycle explained earlier in this report, recurs in an 8-year pattern with remarkable regularity, because 8 Earth years correspond almost exactly to 5 Venus synodic cycles. The Babylonian scribes who compiled this record had, independently and using nothing but sustained naked-eye observation against a lunar calendar, identified and recorded this same 8-year periodicity. The precision of their day counts has allowed modern astronomers and historians, working backward using retro-calculated planetary positions, to use this tablet as a chronological anchor point, a fixed reference against which other undated events in Babylonian history can be calibrated, because the tablet's internal astronomical data can only fit a small number of possible actual calendar dates. This is the origin of the 4 competing chronologies historians still debate today, the high, middle, low, and ultra-low chronologies for the early 2nd millennium BCE, each corresponding to a different possible alignment of the tablet's recorded Venus data against the actual historical sky. The specific entries on the tablet follow a consistent and highly structured format. A typical entry records that Venus disappeared in the west, remained invisible for a stated number of days, and then reappeared in the east, or the reverse pattern for the opposite conjunction, with each entry tied to a specific day within the Babylonian lunar month. It is in the structure of these entries that we find the number this report has flagged twice already. The tablet's records show that a disappearance of approximately 3 days at inferior conjunction, or in some entries extending toward a week, was treated as the unremarkable expected duration. Critically, the omen text accompanying these entries does not treat every disappearance identically. Entries surrounding the longer disappearance at superior conjunction, The same roughly 50-day absence explained in the verified data section of this report carry their own distinct set of omens, separate from the shorter inferior conjunction entries, with a specific duration of the absence treated as the variable that determined which omen applied. The omens themselves are direct and unambiguous in their stated stakes. One frequently cited entry from the broader Enuma Anu Enlil series concerning Venus states plainly that if the planet remains visible steadily in the morning, the omen concerns reconciliation between enemy kings. Other entries across the tablet's full structure link the specific day of disappearance, the specific direction of reappearance, and the specific length of absence to outcomes ranging from agricultural abundance to military defeat to the death or endangerment of a ruler. This is not a record being kept out of idle curiosity. It is a working operational document, maintained and recopied for centuries, that Babylonian court astrologers used to advise their kings on matters of state, war, and harvest planning, with the precise observed behavior of Venus treated as one of the most consequential inputs available to royal decision-making. We are not going to claim that this proves anything about tonight's occultation beyond what has already been established. The Babylonian astrologers who compiled this tablet did not know about orbital mechanics, did not know Venus was a planet orbiting the Sun on an interior track to Earth's own orbit, and built their entire interpretive framework around a cosmology involving named gods and a structured divine hierarchy that modern astronomy does not support. What the surviving fragments and the century of scholarly verification behind them demonstrate beyond reasonable dispute is that the specific cycle this report has spent its opening section explaining in the language of synodic periods and orbital geometry was independently observed, tracked, and recorded with day-level precision by Babylonian scribes more than 3,000 years ago, recorded with enough internal consistency that the document still functions as a working astronomical record today. The pattern is on the record in both places, the cuneiform tablet and tonight's NASA-verified occultation data. The language used by the Babylonian scribes is precise enough in its day counts and its directional entries to be notable enough on its own terms, independent of the omens attached to it. The Babylonian astronomical tradition we have just examined did not exist in isolation from the broader mythology of the region. Centuries before the Venus tablet of Amisaduqa was first compiled, the Sumerians, whose civilization predates Babylon itself and whose cuneiform script is the oldest fully developed writing system known to survive, had already identified the planet Venus with a major deity and had already built one of their most significant surviving myths directly around the structure of Venus's disappearance and return. That deity is Inanna, known in the later Akkadian and Babylonian tradition as Ishtar, a goddess associated with love, fertility, and war, worshipped across Mesopotamia from the Uruk period, predating 3000 BCE through the fall of Babylon and beyond. Inanna's identification with Venus as both morning star and evening star is attested in some of the earliest surviving Sumerian literary texts, and her principal symbol, an 8-pointed star or rosette, appears on cylinder seals and temple reliefs as a direct visual reference to the planet itself. The central myth associated with Inanna, surviving in two related versions, an earlier and considerably longer Sumerian text dating to the 3rd dynasty of Ur in the final centuries of the 3rd millennium BCE, and a shorter, later Akkadian version is conventionally known as the Descent of Inanna, or, in its Akkadian form, the Descent of Ishtar. The myth describes the goddess undertaking a journey into the underworld, the domain of her sister Ereshkigal, passing through 7 successive gates, at each of which an article of her clothing or royal regalia is removed, until she arrives at the underworld stripped of all the symbols of her divine authority. Ereshkigal's judges condemn her, and Inanna is killed, and her body hung on display. After 3 days pass, her loyal attendant Ninshubur, following instructions Inanna gave before her descent, successfully pleads with the god Enki, who sends 2 emissaries to revive her and secure her release, allowing Inanna to ascend back to the world above, though not without a final complication. The underworld's guardians require a substitute to take her place below, and Inanna's consort Dumuzi is ultimately taken in her stead. Scholars of Mesopotamian religion have long identified the astronomical structure embedded directly in this narrative. Venus's disappearance at inferior conjunction, The shorter of the two disappearance windows described earlier in this report, and at superior conjunction, the longer window, both involve the planet passing out of visibility before re-emerging on the opposite horizon in the opposite role, morning star becoming evening star, or evening star becoming morning star. Inanna's descent into and return from the underworld maps directly onto this same structure. A goddess, identified explicitly with the planet, disappears from the world above, undergoes a transformation in an unseen, liminal domain, and returns transformed, having effectively swapped her position in the cosmic order, in a manner that scholars studying the text have described as having a direct astronomical correlate visible to any sustained observer of the night sky. The specific 3-day interval before Ninshuber's intervention has been connected by some researchers to the shorter inferior conjunction disappearance window and to the period during which the moon itself disappears entirely from view around its own new phase, linking Inanna's astral identity to multiple celestial cycles simultaneously rather than to Venus's behavior alone. It is worth being precise about what kind of document we are describing. The myth of Inanna's descent is not a scientific or observational record in the way the Venus tablet of Amisaduqa is. It does not record specific dates or day counts tied to a calendar. It is a religious and literary composition preserved in cuneiform on multiple surviving tablets, studied today through translations including the widely used English rendering by Diane Wolkstein and the Sumerologist Samuel Noah Kramer, alongside detailed scholarly commentary from researchers including Thorkild Jacobson at Yale and subsequent specialists in Mesopotamian religion. What the myth demonstrates is not astronomical precision, but something arguably more significant for our purposes: that the underlying behavior of Venus, its periodic disappearance and reappearance, its alternation between two distinct roles in the sky, was considered significant enough by Sumerian and later Babylonian culture to be encoded directly into one of their civilization's central religious narratives, centuries before the same culture's astronomers began keeping the day-precise written observations that would eventually become the Venus tablet. The data is in the record in both places, the ancient and the modern. The interpretation belongs to you. As this report is filed, the occultation this report opened with is already several hours in the past, the sky over the eastern half of the country already dark, the working day that surrounded this afternoon's brief celestial event already folded into the ordinary business of a Wednesday evening. The moon has continued along its orbital path, having long since cleared Venus's position and moved on to cross the Beehive cluster in the evening sky, exactly as the verified data in this report's opening section described. Venus itself remains exactly where the orbital mechanics say it should be, continuing its current run as evening star, visible after sunset for the remainder of the summer, heading toward its greatest eastern elongation on August 15. Nothing about tonight's event has altered the underlying cycle in any way. The cycle simply continued, as it has continued for as long as Earth and Venus have occupied their current orbits, and as it will continue long after every agency named in this report has been superseded by whatever monitoring infrastructure comes next. Let us walk back through what this report has covered, because the full shape of it is worth holding together as a single picture rather than as separate sections. We opened with the precise, multiply verified data, a 29-second daytime occultation of Venus by the moon, the first of its kind favorable to North America in 11 years, tracked to the second by the United States Naval Observatory's MICA software, the Jet Propulsion Laboratory's DE-440 ephemeris, and the global network coordinated by the International Occultation Timing Association. We established the underlying mechanism, the 584-day synodic cycle that governs when Venus disappears at conjunction and reappears on the opposite horizon in the opposite role, a cycle whose mechanics have been completely and transparently explained by modern orbital mechanics. We then moved through the documented historical record of human observation of this same planet, from Kepler's prediction and Horrocks' first observed transit in 1639, through the international transit expeditions of the 18th and 19th centuries that helped fix the actual scale of the solar system, through Tycho Brahe's painstaking pre-telescopic positional astronomy, and into the modern era of streamed, crowd-verified occultation timing. From there we went further back, into the ancient record proper. We examined the Venus tablet of Amisaduqa, a Babylonian astronomical and omen text whose surviving 7th century BCE copies preserve observations dating back more than 3,000 years, tracking Venus's appearances and disappearances with day-level precision against the Babylonian lunar calendar, precision exact enough that the document still functions today as a chronological anchor for historians dating the broader ancient Near East. We examined the Sumerian and Akkadian myth of Inanna's descent into and return from the underworld, a religious narrative whose seven-gate structure of death, transformation, and return scholars have long connected to the same astronomical cycle the Venus tablet records in numerical form. We crossed an ocean with no possible point of cultural contact and examined the Dresden Codex Venus table, in which Maya astronomers independently arrived at the same 8-year, 5 synodic period structure, recording it in dot and bar numerals across 5 pages, maintained and actively corrected over more than a century of continuous observation. And we connected that record to the Aztec Codex Chimalpopoca's account of Quetzalcoatl's transformation into the morning star, an 8-day mythological count that mirrors the Maya astronomical record's own inferior conjunction figure, with a precision that still draws scholarly attention. We resolved the specific number this report planted early and returned to twice more before reaching it. The Babylonian threshold of approximately 70 days, the figure that separated an ordinary, expected disappearance of Venus at superior conjunction from one long enough to be read as a warning concerning the king and the land. We were careful to draw the distinction between that ancient conjunction threshold and tonight's specific occultation, which operates on an entirely different and far shorter mechanism. The two are not identical events. They are two instances of the same broader category, the periodic disappearance of Venus from human view, independently judged significant enough by multiple separated civilizations to track, name, and number. It is worth dwelling for a moment on the sheer span of time this report has covered, because the scale of it is easy to state and harder to absorb. The Babylonian observations underlying the Venus tablet date to roughly the 17th century BCE. The Maya Venus table, as a physical document, was produced over 2,000 years later, and its underlying observational tradition stretches back further still. Galileo's telescopic confirmation of Venus's phases came in 1610, roughly 3.5 centuries before tonight's occultation. The Naval Observatory's Mica software and the Jet Propulsion Laboratory's DE-440 ephemeris represent the most recent link in a chain of observation and calculation that, end to end, spans nearly 4,000 years, all of it directed at the same single planet, the same recurring cycle, and in a meaningful sense, the same underlying question: where is Venus, and what does its disappearance mean? The tools used to answer that question have changed almost beyond recognition across that span. The fact that the question itself has been worth asking, continuously, across every civilization that has looked up and noticed Venus's brightness, has not changed at all. There are several specific things worth watching in the coming days and months, drawn directly from the verified agency data already covered in this report. First, the International Occultation Timing Association's published schedule places the next lunar occultation of Venus on September 14, favoring observers across Southeast Asia, with a third event on November 7 favoring the southern tip of South America, neither visible from North America. Second, the contiguous United States will not see another favorable daytime occultation of this kind until the 2029 to 2031 window, a gap of 3 to 5 years from tonight, a date worth marking now for anyone who wants to plan ahead for the next viewing opportunity. Third, Venus itself continues toward greatest eastern elongation, its maximum angular distance from the Sun in the evening sky for this apparition, on August 15, a milestone worth marking on any calendar for anyone who found tonight's event compelling, since elongation typically offers the year's best extended viewing window for the planet after sunset. Fourth, NASA's Jet Propulsion Laboratory continues its routine tracking of near-Earth asteroid approaches through the Center for Near-Earth Object Studies, and the Space Weather Prediction Center continues daily monitoring of solar activity and geomagnetic conditions, both of which this report touched on briefly in establishing the broader monitoring context surrounding tonight's occultation. Fifth, the Dresden Codex itself remains an active subject of ongoing scholarly research, with the most recent reinterpretation of its introductory page, connecting the manuscript's astronomical correction directly to Chichen Itza, published within the past several years, meaning the ancient record covered in tonight's report is not a closed or fully settled body of scholarship. It continues to be studied, refined, and in some cases, revised by researchers working right now. Sixth, Venus will eventually cycle back toward its next inferior conjunction disappearance later this year. The shorter, roughly 8-day window, this report connected directly to both the Babylonian and Maya records, and we will be watching the agency calendars for the exact date as it firms up. There is a final reflection worth sitting with before this report closes, one that connects everything covered tonight back to the single observation this report opened with. This afternoon, an ordinary Wednesday, people across an entire continent had the opportunity to step outside, find a patch of shade, and watch the brightest planet in the solar system vanish behind the thinnest sliver of moon for no reason other than the fact that two bodies in space happened to align as they periodically do. Most people did not look up. This is not a criticism. It is simply the reality of how a fully explained, fully predicted, fully safe astronomical event sits within a world full of other demands on attention. But for the people who did look up today, who found the shadow of a building, located the thin crescent against the blue afternoon sky, and watched Venus disappear and then, nearly an hour later, reappear, they performed an act that connects them directly to an unbroken chain of human observation stretching back through Galileo's telescope in 1610, through Tycho Brahe's quadrants at Uraniborg, through the Maya astronomers correcting their calendar at Chichen Itza, through the Babylonian scribes copying and recopying a 3,000-year-old observation at Nineveh, all the way back to whoever first noticed, with nothing but patient attention and no instrument at all, that the brightest object in the morning sky sometimes simply was not there, and then, reliably, returned. The instruments have changed completely. The underlying human act of looking up, noticing, and keeping count has not changed at all. That continuity is, in the end, the case this report has tried to make tonight, without overstating it. This report is not claiming that the Babylonian astrologers or the Maya astronomers understood orbital mechanics, and it is not claiming that today's occultation carries any meaning beyond what the orbital mechanics fully explain. What this report is documenting is that the impulse behind their records, the decision that this specific planet's behavior was worth tracking precisely, recording carefully, and preserving across centuries, was not misplaced. Venus's cycle turned out to be real, measurable, and predictable, exactly as precise as their day counts suggested it was, long before anyone could explain why. That is not a small thing for a civilization with no telescope to have gotten right. We have filed reports on solar flares, on volcanic eruptions, on shifting fault lines, and on an interstellar comet that passed through this solar system and will never return. Tonight we filed a report on something gentler and, in its own way, just as old, a planet doing exactly what it has always done, watched by people doing exactly what people have always done in response. What we try to do every night is hold both layers up next to each other, the verified modern data and the documented ancient record. Without forcing a conclusion neither layer fully supports on its own. Tonight's report laid out the full layer beneath the headline. Not just that Venus disappeared, but why, how precisely 3 independent agencies tracked it, and what 4 separate ancient civilizations independently recorded about this exact cycle long before any of those agencies existed. That second layer is what gets missed reading a single news alert about today's occultation and moving on. We file a report like this every night on a different event with the same standard of sourcing. Subscribing is how tomorrow night's report gets delivered alongside this one. Tell us in the comments where you were tonight and what to look at next. What happens next in the sky and in the historical record beneath it is on the record. We remain in observation.